All right, let's talk about more about relative dating. So we talked about how fossils can help us relatively date the age of a rock sample. Now we're going to talk about this law of superposition, and we briefly touched on it in our fossil lecture. So this should sound familiar, but we're going to go over it again a little bit in depth. So to start with your notes, before we start, we've got to travel back in time to 6th grade science. Back to the future or back to the past to be more exact. So in 6th grade science, you should have learned the types of rocks. There are 3 of them: sedimentary rocks, metamorphic rocks, and igneous rocks. These 3 are distinguished because they form in different types of ways. We've got our example of a sedimentary rock, a metamorphic rock, and an igneous rock right here on the screen. They are named such because they form in a particular way. First off, our sedimentary rocks. They are formed when particles of sand, shells, pebbles, dust, dirt, aka sediments, come together and are cemented and compacted into one solid rock. These are usually the only types of rocks that contain fossils. Again, because the heat and the pressure of metamorphic and igneous rocks will often destroy biological remains, so those do not usually form fossils, but our sedimentary rocks will, because the forces that form them are, again, cementation, so sticking those sediments together, and compaction, squishing them together. So those will typically allow for organic remains to remain in the rocks, and that's how we get fossils. We will study the sedimentary rocks and the rock cycle in general in Earth and Environmental Science next year, so I'm really excited. We'll go more into depth and talk about how exactly we get these sediments. Our next type of rock is called a metamorphic rock. These rocks are formed under the surface of Earth from the metamorphosis or change that occurs due to 1, intense heat, and 2, pressure. If we did not have that intense heat or we didn't have the pressure, our rock would not form. They look similar to sedimentary rocks in the sense that they can also be striated or have these distinct bands, but they are metamorphic because of that heat and pressure, so those molecules in the sediments are often melted together and squished together. Again, metamorphosis, big word. All it means is change. Different kinds of organisms go through metamorphoses, like caterpillars into butterflies, tadpoles into frogs. It's just a fancy word for change over time. And our very final rock is the igneous rock, and these are formed when magma or lava cools and hardens. Again, the difference between magma is that it is under the ground, and lava is when our magma comes to the surface. So lava, surface, magma, under the ground. That's not something necessarily that I would test you on yet, but you will be tested on that in Earth and Environmental, and I'm a stickler about it because those words are used interchangeably by the common person, but in science they mean 2 very different things. So this is when the rocks, the magma or the lava cools or hardens. This is the most congruent type of rock, meaning that it's pretty much all one shape and color. So where our metamorphic rocks kind of look like a hodgepodge, and our sedimentary rocks definitely look like a hodgepodge of sediments and other rocks, igneous rocks are usually one color, one form. We don't see like splotches of different colors or elements in there. They're all congruent or the same for the most part. And that is why we can absolutely date igneous rocks more easily, because the different elements are put together, melted together. Think like if I took crayons, like all different colors of crayons, and I melted them all together and made one big brown crayon, because that's what would happen if you melted all the crayon colors together. A metamorphic rock would be like if I took a sedimentary rock would be like if I took a crayon and I shaved it, like I made little pieces of the crayon, and then I just used my hands and squished them together, maybe. That would be a sedimentary rock, so I could still see the individual pieces and colors of the crayons. They would just be all one crayon together. A metamorphic rock would be like if I stuck it in the microwave for 5 seconds and then squished it. So they would kind of be melted together, but you could still see those each individual colors. But a igneous rock would be like if I melted the crayon completely and then it became all one color, one substance, and let it cool. Cooling is the important part. If it's not cool, it's not a rock. Rock dating, that's what we're getting to. I got a funny cartoon again for you. So one rock says to the other at the quarry, so I was dating this chick who I thought was igneous, but turns out she's actually metamorphic. Whoa, man, that's messed up. One of the many perils of within the rock dating scene. You never know what kind of rock you're gonna get. Alright, just a funny. The law of superposition, again, we learned about this a little bit when we talked about fossils, but this is the law that tells us that the oldest rock is actually on the bottom when we're talking about our layers. Now this is just with our rock layers, and I want you to know, though it's not always, most of our layers of rocks are sedimentary rocks, but when we're talking about a mountainside like this, with huge layers of rocks, some of these layers could actually be metamorphic or igneous rocks, depending on how the original structure formed. But typically, the law of superposition says that the oldest rock is going to be at the bottom, and the rocks will get progressively younger as you move towards the top. So this is the oldest rock. This might be the second oldest rock layer. This might be the third oldest rock layer, and so on and so forth. So as you move up the rocks, we're getting younger. Think about it again, like we said the other day, the first layer must be there for the other layer to form, and so forth and so forth. Again, another example. The top layer is the youngest, the bottom layer is the oldest. This sandstone layer right here is older than all the layers on top of it, while this limestone layer right here is younger than all the rocks below it. If we picked a middle layer like this Cocanino sandstone, we're going to go with that's how you say it. This is younger than all the rocks below it, so your shale and your sandstone right here, but it is older than the two layers of limestone on top of it because it is lower on our layers. Again, that's the law of superposition. You can see these layers even in famous places. There's another name for it. Even with famous geological features, that's still not it, but that's closer. The Grand Canyon, so the layers that you're seeing at the bottom of the Grand Canyon are older than those on top. Now don't forget that even underneath this grass right here, there is layers of rocks. So if we took the grass off, we could see even older layers than what are exposed right now. So it's pretty cool. So if you ever visit the Grand Canyon, I would like you to know that the older layers closer to the bottom of the canyon are older than those on top. Again, horizontal layers of rocks, it's beautiful. Definitely something I would like to see in person sometime, but these are our horizontal layers. Now they've gotten a little funky, and we'll talk about why they look funky like that, and they're not straight. This is called the Wave at the Vermilion Cliffs Wilderness near the Utah-Arizona border. Funny. I know a family named Vermilion. Wonder if they're famous. I don't know. Okay. Unconformity. So this is when we have gaps or missing layers in the rock record due to erosion. Here you can see that our layers are no longer up and down horizontal. They've moved sideways. We have a couple of different things that can cause this unconformity, and we'll talk about it in a second. One of those things is the movement of the tectonic plates. Let's see if we say that. I don't know, maybe we won't say it. But the movement of the tectonic plates can cause these layers to flip on their side instead of being on top. Now, we can have our layers flip on the side and nothing will be on top of them, but as you can see with this right here, our layers flipped due to tectonic plate movement or some other factor, and then another layer of sediment gathered and became rock on top of it, and it will continue on top as time goes on. So really cool the way the rocks might change. So an example of unconformity, the local record that the time interval is missing, and geologists must use other clues to discover the history of that site. So again, sedimentary rocks form in horizontal layers. Folding or tilting of the rock layers can happen, like with our canyon picture that we saw the other day, due to the tectonic plate movements. And then the surface can be eroded, so we might actually lose some of these layers due to the weathering and erosion of the sediments there, which we'll learn in Earth and Environmental History is very, very common. It can be done through the wind or the rain or ice or human travel or pretty much anything that's beating along the rocks. And then an unconformity happens when new sediments are deposited on top of that eroded layer. So instead of getting the nice lines like we had before, we're getting kind of a wonky picture of what the geological record looked like. So instead of getting those nice horizontal layers, we're getting an unreal picture based on the rocks of what's happening in the geologic past. Another thing that can happen that'll disturb our rock layers is called intrusion. We talked about this when we did our fossil record again. So this is when magma cools beneath the surface of the earth. When magma cools beneath the surface of the earth, it's called intrusion. Intrusions are always younger than the rock found around it, and then the rock it cuts through. For intrusion, think inside. So here's an example of intrusion. So the igneous layer, or the igneous intrusion, the magma, sliced up into our sediment layers here and eventually cooled, forming an igneous rock. Now remember, the igneous rock is always younger than the layer it cuts through. Not necessarily all the layers in the picture, but definitely the ones that it cuts through. If it hardens and maybe even forms a layer like up here, then it is older than any of the layers that have stacked on top of it. Remember, our igneous or intrusion is always younger than the rocks it cuts through. We also have examples of extrusion. This is when lava cools above the surface of the earth. Extrusions are always younger than the rocks around it. For extrusion, think outside. X means outside, in means inside. Okay, so here we've got our original rock layers, A, B, C, D, E. They are all sedimentary rock layers. Then, first of all, which rock layer is the oldest? Based on the law of superposition, we know that A is the oldest, B is the second oldest, then C, then D, then E, E being the youngest in this picture. There, an intrusion happens. So the intrusion cut through rock layer A, B, and C, and it is now younger than the surrounding rock layers. Again, because this is inside, we call it an intrusion. All right, now say a volcano erupts and lava, because it's on the surface of the earth, cools on top of all of these rock layers. What do we call that when it's gone to the outside of the surface of the earth? We call that an extrusion. It's on the outside. It is younger than all the layers that is below it. More rock layers are often deposited on top of the extrusion. Now again, those are younger than these because this extrusion must have cooled and formed before the other rock layers could have happened. We'll call those F and G. Last thing, a fault. A fault is the break in the Earth's crust. A fault is always younger than the rock it cuts through. Faults move over time, making determining the layers of the rocks confusing. So here's a fault or a cut along the surface. You can see it's almost like we took the rocks and went and slid them past one another. This is often caused by the movement of the tectonic plates. Again, here we go. So we've got the rock layers nice and steady, but we've got a fault that's broken through into the rock, and all of a sudden we have tectonic plate movement and, the crack in the rock is called a fault. All of a sudden we have tectonic plate movement and they break apart and they move. And then, as time goes by, more rock layers are added to the top, making it difficult to age the layers of the rock. Ta-da! And that's the end of your lecture. Turn in your notes. You are done for the day, and be ready for review on Monday and your test on Tuesday. Remember that. You have a test on Tuesday, review on Monday. If you have any questions over the weekend, say you get a head start on studying, email me with questions. Have a great day, guys.